So I'm going to be going through applications of exponential functions right now. It's from Unit 7. It's the last section in this unit, so there will be a test coming up shortly. So let's go through a couple of applications. So there are some formulas that you need to know. The first one is going to be anytime you have an initial value, which is a sub 0, so that's your starting value, and it's being increased or decreased by adding or subtracting some percentage. The formula that you're going to use for that is a, or your amount, equals a sub 0, which is your initial amount, times 1 plus whatever your rate is, raised to the t power. So a is your amount, a sub 0 is your initial amount, lowercase r is going to be your rate, and that's as a decimal, and t is going to be time. So let's go through a quick example of this. So Amanda won $10,000 and decided to use it as a vacation fund. So her initial amount, her A, is going to be $10,000. Each summer she withdraws an amount of money that reduces, that's going to be important, reduces the value of the fund by 7.5%. So her rate is going to be 7.5%, which if you write that as a decimal is going to be 0.075. 0.75% from the previous summer. How much will the fund be worth after the 10th withdrawal? So T is going to be 10, because we're looking for withdrawing each year for 10 years. So we're going to go ahead and plug this into our formula, which was A equals a sub 0, 1 plus r to the t. So that means we're going to have our initial amount is 10,000 times 1. Now it's important that it says reduces the value. That means that this is actually going to be a negative down here. So we're going to have minus 0.075 raised to the 10th power. From that, it's just a little calculating, so that's 10,000 times 0.925 to the 10th power. And if you put that into your calculator, you actually end up with $4,585.82. So that's the first type of problem, is just having a straight compound problem, which uses exponents. The second example is a little different now. Sometimes the percentage of increase is applied more than once per year. So you apply it every month or every quarter, every half year. So when we do this, the formula changes just a little bit. So it's actually going to be now A equals a sub 0 times 1 plus r over n raised to the n t power. So again, A is going to be your total amount. A sub 0 is still your initial amount. R is still your rate as a decimal. T is still time. But now N is going to be the number of compounds per year. And I think that's going to go into the little logo in the corner. I'm sorry if it does. So that is your new formula. The things that change are now you have your n's here, taking into account the number of compounds each cycle. So for an example, how much money should you put into an account if you want to have $400 in 3 years? If the account earns 5% interest compounded quarterly. So we need to figure out A0, R, T, N. Okay? So right away I see that the account earns 5% interest. So my rate is going to be 0.05 because that's 5%. I see a time up here, which is 3 years, so that's going to be my time, which is 3. And then I also see that down here it says it is compounded quarterly. Well, quarterly means that's 4 times per year, so n is going to be 4. And I also notice that they say you want to have $400 in 3 years. So that's not your initial amount, that's actually going to be your total amount in 3 years. So A is going to be 400 this time. So our original equation is going to be A equals our initial amount times 1 plus R over N to the NT. So now we're just going to plug things in. And in this case, A is 400. So this is 400 equals, we don't know our initial amount. They want to know how much money should you put in, times 1 plus 0.05 over 4 to the 4 times 3. So that's going to be 400 equals A0 times 1.0125, if you put it in your calculator, to the 12th power. And I'm just going to go ahead and divide by this whole thing. So this whole thing cancels out, and I'll get A sub 0 equals $344.60. So that means that if I deposit $344.60 and it earns 5% interest compounded quarterly for 3 years, I will have $400 in my account. All right. The last type of problem is continuous compounding. So when it's compounded continuously. Now this one sounds a lot trickier, but it's actually not any more difficult. So as soon as my drawing mode comes up here, so continually increasing or decreasing. The formula is going to be A equals our initial amount, that E we talked about the other day, to the RT. And again, A is your amount that you have at the end. A sub 0 is your initial amount. E in this case is just going to be E in the calculator. R is going to be a rate, and T is still going to be time. So one quick example on this. So the decay constant of radium is that crazy decimal point, 0.0004 per year. How many grams will remain of a 50-gram sample after 20 years? So our initial amount, A sub 0, is going to be 50 grams. Our rate is that negative 0.0004, and our time is going to be 20. So looking at our formula, which was A0 E to the RT, and now we just plug in. So our amount is going to be 50 times E to the negative 0.0004 times 20. So that's 50 E to the I didn't even do that in my calculator. Whatever you get when you multiply that out. But when you put the whole thing in, so I think that's negative 0.008, I think. And when you put those in to get that decimal, you end up with 49.6 grams. So that means that in 20 years, it would go from 50 grams, and it would only go down to 49.6 grams. So after 20 years, only 0.4 of it has decayed, has gone away. This last example here, I would like you to set up, so I want you to figure out all of the pieces that you need. So your A0, your rate, your time, all that good stuff. N if it's in there, so figure out each of these. And I want you to figure out which one of the formulas you need. So is it A equals A sub 0 times 1 minus R to the T? Is it A equals a sub 0 times 1 minus r over n to the nt, or is it a equals a sub 0 times e to the rt? So you need to set this one up, and we will go over it first thing in class tomorrow. So you need to figure out each of these and pick a formula. Other than that, I will see you tomorrow. Have a great night.